Professor of Biomedical Sciences at UCR. For the last 8.5 years, Professor Nordgren has been working and studying on the effects of agricultural dust exposure on lung inflammation and health. So she's very well suited for this topic and for this panel. So let's give her a round of applause.
Thank you so much for that introduction. And I really appreciate the opportunity to come and be a part of the summit and to be the moderator for this session today. I've learned quite a lot so far today. And I know this is a topic that has come up throughout the day, so I'm looking forward to a good discussion on the impacts of air quality and health. So just to briefly introduce who's going to be talking today in this session, so we're going to hear a little bit about the regional air quality and dust sources from Earl Withycombe. We're going to hear about the current and potential playa emissions from Brian Schmid. And then Will Porter from UCR is going to be talking about the chemical composition of the playa dust. And we're going to round out the discussion with the public health impacts from Shohreh Farzan. And so I don't want to take any more time from the speakers today, so I'll go ahead and hand it over to our first speaker, Earl Withycombe.
Two of the fundamental questions people have been asking in this region are how much windblown dust is being generated by exposed Salton Sea playa, and how will dust emissions from the playa be controlled to levels that are protecting the public health? And these two topics I'm covering. One of the metrics used to assess trends in air quality is an analysis of annual averages. This is a plot of annual averages in community air stations in the Coachella Valley and the Imperial Valley. And this runs from 1988, when the PM10, or particulate matter smaller than 10 microns in size, was established by US EPA. The general trend is downward. I'm just looking for a pointer and I brought my own. Is downward, which is an encouraging sign. The fluctuations are basically driven by changes in meteorology each year and primarily high wind events. In 2010, IID, through the funds provided by the Joint Power Authority, basically funded the construction and operation of 6 shoreline monitoring stations that monitor PM10 and meteorological conditions. And these sites are located at Bombay Beach, Sunny Bono Wildlife Refuge, Naval Test Base, Salton City, and the Torres Martinez Wetlands Project, and the Salton Sea Park headquarters. The similar corresponding trends at those stations show slowly increasing concentrations on an annual basis, which is sort of to be expected because of increasing expanses of playa. The 2015 data here is not entirely representative because of significant delays or periods of time when the instruments were not operating. And so the 2015 data is not representative. But basically, we're seeing a slow upward trend, if any. Again, the variations are due to the meteorological conditions each year, and to also with the soil conditions, soil moisture conditions especially. Another metric used is the number of days on which the 24-hour federal PM10 standard is exceeded. And here I've broken the graphs into northern sites, both community sites in the solid lines and shoreline sites in the dashed lines. And basically the trend is good for the Palm Springs sites, site and the Salton Sea Park. We see substantial variability in the site at Indio and also at Torres Martinez. And in a minute, I'll sort of explain why some of that is occurring. The sites in Imperial County show similar conditions, but I want to mention one thing. Notice that the scale for the Riverside sites goes to 14. Here it goes to 80. So what we're seeing is that the sites in Imperial County, especially the two sites on the west shore, the shoreline stations at Salton City and Naval Test Base, report substantially higher concentrations than anything we see in the Riverside County sites and anything we see in the community sites. The community sites show basically sort of flat line, little change in the number of exceedance days over time, and the shoreline sites are more variable, especially those two on the western shore. The interesting outcome of an analysis of wind conditions that I did for the most recent year we have full data, 2018, show these sorts of wind roses. These wind roses represent the direction that the wind is coming from for all hours during which the wind speed is above 12 miles per hour. 12 miles per hour is about the lowest wind speed that will cause sand particles to bounce across the surface of land, which is the driving force behind wind-blown fugitive dust almost in any environment. And so these high wind hours show very clearly that in the two western shore sites at Salton City and Naval Test Base, the winds are coming from very almost a unilinear direction with very little spread, coming from the west over the Coast Range and across these desert lands into the communities of Salton City, for example, and then out over the sea. We see the same thing at the Sunny Bono site. At Bombay Beach, we see more variation. Bombay Beach is affected, the highest winds from Bombay Beach come from the west, from the sea, but the town itself is downwind of exposed playa. Some of the high winds come from the direction that we see at the northern shore, which are winds that come right down the Coachella Valley and down across the sea. The two sites at Torres Martinez Wetland Project and at the Salton Sea headquarters, park headquarters, the high winds come predominantly right down the Coachella Valley from northwest to southeast, but and with very limited flows from exposed playa into these two sites. This information suggests that the communities that will be most impacted as playa exposure increases are going to be those communities on the southwestern shore of Salton Sea, Bombay Beach, Nyland, and Calipatria, and to a lesser extent, but unknown at this time because we don't have any monitors at this location, Delta Shores or Delta Shores will be impacted by exposed playa in this area from the outlet of the Whitewater River to about Trapeze Point. This predominant wind direction may carry dust from exposed playa in this area to this community. But the impacts from that we saw at Salton City and Naval Test Base that are significantly higher than the community stations in the Imperial Valley is not being driven at this time by dust coming off the playa, but instead dust off the desert. I analyzed the exceedance days from 2018 at the shoreline stations and analyzed the wind directions for each hour that the concentration was above 150 micrograms per cubic meter. This is the result. Salton Sea Park had 2 days of non-attainment, and both of those days, the winds came from the playa, or from the inland areas to the site, not from the playa areas. The same thing happened at Torres Martinez that recorded 11 days of exceedance. For the Imperial County sites, the Bombay Beach site, 80% of the hours on exceedance days, the wind was blowing, the high winds, wind was blowing from the lake and from the playa to the community. Only 20% or 1 day did the wind come from a direction other than from the playa to cause an exceedance. The same thing occurred at Sunny Bono, down here at the bottom, where 4 days of exceedance, the wind blew from the playa to the monitor on all 4 days, but one of those days, the winds blew in 2 different directions. So one of those 4 days, the wind blew part of the day from the non-playa areas, from the inland areas, and the rest of the day blew from the playa areas. At the Naval Test Base and Salton City sites, the winds predominantly from 98%, 89% respectively, blew from the desert lands to cause exceedances at those 2 shoreline stations, and only 10% of the exceedance days did the wind blow from the east, from the playa. This is a map of emissions on an annual basis that I have stolen from Brian, our next speaker, who will cover this more in detail. But his analysis for the period from July 1, 2017 to June 30th, 2018 indicates that, and these are heat maps, these are emissions in tons per square kilometer over a year, show very high areas or hot spots in playa areas near Salton City and to the north, and in the desert areas or the shore plain areas inland from there. But the comparison of emissions from the exposed playa to the desert lands, which are feeding windblown dust into not only the Salton Sea area, but also into the Imperial Valley area, the emissions from the desert lands are about 100 times greater in this particular 1 year period than the emissions that are coming off the playa. And he'll explain how the methodology by which he arrived at that estimate. Basically, as I mentioned, windblown dust is caused by sand particles beginning to bounce across the surface, called saltation. Every time a sand particle lands on the surface, it breaks apart soil aggregates and causes the finer particles to be suspended. One of the big problems that we're facing is sand inundation being moved by precipitation events in the western shoreline. These are 2 pictures of the Salton City monitoring station before and after a precipitation event that occurred in April of 2014 and inundated and put about 9 inches of sand all across that area. The next time we had a high wind event on May 10th, 2014, we recorded a 1 hour PM10 concentration of almost 40,000 micrograms per cubic meter. Federal standard for a 24-hour period is 150. That 40,000 approaches the highest levels we've seen at Owens Lake. We also have encroaching sand dunes that are moving in mass near the Naval Test Base. And this is what's causing high concentrations at that particular shoreline monitoring site. So the challenge in air pollution is to stabilize the sand and keep sand that's now migrating out of the battlement areas in Anza Borrego away from the shoreline, which is going to be an interesting challenge to resolve. These are just pictures of control projects that Brian's going to speak more to. The findings to date are there are few discernible trends in PM10 air quality. The communities are going to be primarily impacted in the future and currently are Bombay Beach, Calipatria, and Island, because they're primarily downwind exposed playa. Windblown dust is not impacting these communities today as much as others in the basin, and those are community stations. Affordable dust control measures are available, and they're being installed. Mitigating sand on the west shore of the Salton Sea is causing the highest PM10 concentrations and will significantly increase playa emissions unless stabilized on the coastal plains. Thank you.
Great, now we're going to follow up that discussion with talk from Brian Schmid.
Good afternoon. My name is Brian Schmid. I'm a soil scientist agronomist with Formation Environmental. I've worked with IID on the Salton Sea Air Quality Program since roughly 2005. I'm going to talk about a lot of the things that IID has been doing. I'm going to try and keep my presentation to 15 minutes, but IID has been doing a lot. I think there's a couple of important brochures or pamphlets that we put together. One's for the public, and these can all be accessed on IID's website. This is a lighter version, but kind of outlines sort of at a high level what the air quality program is, what's being done, and what the future challenges are. And then there's a second one that's a little bit heavier. Wouldn't recommend reading it at night, but it goes into a little bit more detail about some of the projects and again, some of the challenges moving forward. So if you look at the air quality program and you read the first paragraph, the goal of the air quality program is to proactively detect, locate, assess, and identify options to mitigate dust emissions from the exposed Salton Sea playa. IID has built a sort of a program of 3 pillars to accomplish that objective. And I'm going to talk about the first part, which is the estimating emissions. And the reason this is important is because we need to understand where the emissions are coming from to plan projects proactively and strategically to deal with those in the future. My colleague, Jessica Humes from IID, will be looking at and talking about the second and third step, the planning and design, and the implementation and monitoring. So what do we mean and what are we trying to do when we say we're going to estimate emissions? There's kind of 3 basic questions. Where and when do dust emissions occur? How much dust is emitted? And which areas of playa should be prioritized for dust control based on that information? And we put this kind of infographic together, tried to break down a complex process into four pieces. The first is you have to understand where playa exposure is occurring. You have to understand where it's going to occur in the future. As you can see, from 2016 through 2019, we go from 16,500 acres to almost 26,000 acres. Once we know where the playa exposure is, we can characterize it. Not all surfaces are created equal, and I'll talk a little bit about how we're doing that. Some are more emissive, some are more resistant to erosion and more protected. But really what we're interested in is where those surfaces are at that are potentially emissive and where they're coupled with persistent high winds. And ultimately all that feeds into estimating emissions. And again, this is an adaptive program. We do this every year because we know that the sea is changing. Not only is the sea changing from the standpoint of more playa being exposed, but the longer that playa is exposed, it does evolve itself, and we want to be able to capture that understanding. So this is probably one of the more simplistic maps I'll show. This is end of year playa exposure. So we, at the end of each year, so if you look at the sort of hydrologic cycle of the sea, in the December timeframe is always the lowest point in terms of elevation. So at that point, we evaluate sort of maximum playa exposure. This is a simple map that just breaks it up into sort of the orange being bare exposed playa. You'll see a lot of green. That's areas that are heavily vegetated. You heard other speakers in the panel this morning talking about how that vegetation seems to be expanding. And if you look at right here, from 2017 to 2018, we had a significant increase, not only in total exposure, but of the amount of acres that had heavily vegetated surfaces on the playa. We expect, so again, from 17 to 18, we had about 2,300 acres of actual exposed playa increase. And as other people have talked about, that's going to increase substantially over the next several years. We are planning to do the end of year 2019, but we project that it's going to be that additional 5,200 acres. And if you are interested, there is a flight tomorrow. Mike's no longer here, but I think we are actually doing a flight tour, and we can actually show you where some of this playa exposure is occurring. Once we know where it's at, we need to understand its conditions. As a soil scientist, I sort of think like a soil survey, but here what we have is what we call surface survey. So we have certain crusts where we don't have a lot of cohesion. These are coarser textured soils. They're less stable, more emissive. To soils that have maybe finer texture conditions, lower depth, shallow depth of groundwater, and with evaporation and time, we get a nice salt crust. But these things can change. You can go out there at one point of the year and see a very stable salt crust. You can go back, quite frankly, a day later, and they've changed substantially because of time, evaporation, precipitation, wind, all the things that are more dynamic that can affect these surfaces. So we map these on a regular basis throughout the dust season. We also quantitatively evaluate them from an emissions potential standpoint. So this is a device called the Portable In Situ Soil Wind Erosion Lab, or PISWIRL. IND has 2 of these units. I don't think there's any place, any terminal lake bed that I know of that has more PISWIRL measurements completed to date. Last year alone, we did about 2,000 of these tests that tell you essentially how much PM10 would be emitted on a particular surface at different wind speeds. So essentially kind of creating essentially an emission flux by wind speed over time. So these surfaces, we have quantitative data that we can then use in our emissions estimate. We also measure and model wind and dust emissions. This is just a subset of stations that IID operates, anywhere from air quality monitoring stations that measure PM10 that Earl presented data on, to sets of portable meteorological stations, to a larger and growing network of what we call round shot or 360-degree cameras. I guess the important part of this is we use this as well as other meteorological stations to feed into what is called the weather research and forecasting model, which gives us sort of hour by hour estimates of wind speed and wind direction, which we can then match up with our information that we're getting from the PISWIRL and from the plot. So I'm going to have an animation, hopefully it works. So before I get started on this, and instead of running on the left, this is output for May 16, 2017. This is wind speed, so the warmer the colors, the higher the wind speed. You'll see white lines that are moving. Those are called streamlines. They're showing you the direction of the wind. On the right is the actual the PM10 being emitted at each hour during the time step. And then the graph is actual playa emissions, not necessarily the desert, but the playa emissions throughout time. And so I'll get them, and you can see that as these winds start to pick up, you'll start to see areas over here light up where those surfaces are potentially emitting dust. It's working. So we'll just kind of watch this. We'll step through it. You'll see as the windstorm progresses, these are westerly flows coming from west to east, headed in this direction. As the day goes on, you start to see that this is starting to light up. At the same time, we're expecting emissions in this area. And then the next time step, I think we start to see higher winds hit the Salton City area. Again, now you're starting to see that, and you're starting to see the areas light up over here from an emissions standpoint. And again, remember, we're doing this for every hour of every day for the last 4 years worth of data. So we essentially aggregate all of this throughout time to help us get an idea and build the heat map that Earl showed in his presentation. Let's play. So here's kind of the end result. This is just on an annual basis. This is tons per square kilometer in terms of emissions of PM10. We have a 2016-17 dust season. So we sort of break the dust season into, instead of calendar year, we go from July 1st through June 30th of every year. So 16-17, and then this most recent 17-18. We just finished the 18-19 dust season, and we expect to have that data in around the first of the year. But what you can start to see is trends, right? So the warmer it is, the more emissions that we see. Those are the areas that we then use in terms of prioritization, because at the end of the day, we're not just concerned where the emissions are come from. We want to understand that so that we can help guide where and why projects go on the ground. So you can see in this, what we call Thule Fan outside of Salton City, the area over here of San Felipe Wash is another high area, and then you can see the deltas. So not only can we look at it spatially, but we can look at it tabularly. This is shows the main surface types by year, and I kind of point to what I highlighted as 6 different numbers. So in terms of total emissions, what we're seeing from the playa is about 374 tons per year. In 2016-17, we saw about a 20% increase year over year from 2017 to 2018 to 447 tons. Obviously, in terms of magnitude, we're at just the beginning of playa exposure. We expect this to, this trend to continue in terms of new sources coming online. But again, I'll go through the prioritization component, which ultimately is designed to proactively put projects on those areas to keep this number at a low level. I also mentioned the desert, and Earl talked about the desert quite a bit. You can see that of the red, a lot of it's from the desert. We care about it for a couple reasons, because it impacts our projects in 2 ways. One, we have these large plumes during those big events that I showed you earlier, where it becomes very difficult to understand what's coming from the desert and what's coming from the sea. So we want to make sure that we understand that and can quantitatively understand those sources. And we care about it. I stole this from Earl. This is where areas in terms of sand dunes are migrating onto the playa. Essentially what we found is that it makes it 5 to 8-fold more emissive where sand is coming onto the playa versus areas where adjacent undisturbed. So stopping this and controlling this is fundamental to controlling playa emissions. And ultimately, I'm almost up. We use this information in terms of prioritization. So to me, this is the important part, and I'll kind of start first with my graph up here. So the area in red, so essentially we have the percent playa acreage, and then here we have percent contribution to the total PM10 emitted. And what you see is that what I have highlighted in red is only 5% of the acreage. Very small percentage of the acreage accounts for 37% of the emissions. And as you go through, 10% is just shy of 60% of the total emissions. And it's that old kind of 80-20 rule that actually holds true here. 20% of the playa exposure in terms of acreage is contributing over 80% of the total emissions. So when you think about prioritization, where those projects would go, if you just blindly put projects out there, there's a significant portion of the playa that you would have no benefit to air quality. So the important part, and the reason IIT is invested in this so much, is that we want to put projects, dust control projects, where they're needed, and do that in a proactive manner. And then lastly, I'll just kind of highlight where Jessica's going to start, and that's in terms of the types of dust control measures that we have out there. There's a whole other part of our program that's designed to a set of plot and field scale studies that are designed to gain experience and get projects on the ground. They're a combination of roughening, whether it be with soil or be with vegetation, soil and vegetation. But we have a sort of a series of strategic sites identified, again, from the emissions monitoring data. And there's essentially a design life, like a pipeline, if you will, where you identify your sites, you characterize them, put site-specific dust control measure designs together that are going to be effective. You design them, and then you implement them. Our goal is that this continues to get larger in terms of sites on the ground, but where these sites are at, they're having a huge impact in terms of avoiding emissions. So with that, take questions at the end.
Since we're going to be moving, will Blair give us a little bit of insight into the composition transport of the best particles?
Yes, my name is Will Porter. It's a real pleasure to be here and to speak with you today about some topics, including dust composition, transport, and health. There's a lot of overlapping areas from what we've already heard and what we're going to hear coming up here. I also say in advance, just as a big disclaimer, that very little of what I'm showing is my work. So this is something, I'm a little bit of a pinch hitter. I'm going to be presenting initially some work that was done by my colleague, Roya Bahraini, and her student, Alex Fried. And this is going to be some work looking at the elemental composition of this dust. And I'm also going to be kind of representing and introducing the work of the Breathe Center at UCR, which myself, Tara Nordgren, and also Dr. David Lowe over here are all members of, looking at the health connections of these kinds of elements, these dust particles and other aspects of air quality around the Salton Sea. So to begin with, I'm going to be looking at and bringing up some of the key elements of this paper that just came out this year. This was a paper that Roya and Alex put together where they did some work looking at this question of what do we know about what's in Salton Sea dust? What do we know about what's in there? That question, one way that we can investigate that is an elemental composition analysis. And so what was done, I'll explain what that means. What was done in this particular case was a few sites, so 5 sites here were set up around the Salton Sea area. You can see the map here. Obviously, it's a little bit sparse in terms of coverage, and that's a problem that we hope to improve with ongoing work as we go forward. And then dust was collected through these passive samplers. So basically, these bins were set up with marbles inside to make a lot of surface area that dust can stick to. And then these bins were basically with duplicates just to make sure that you're getting some good coverage and making sure you're covering your bases there. We're set up to collect this dust, and then it was brought in about monthly-ish, very technical term there, from May 2017 to about a year later, April 2018. That chemical composition was then analyzed with a couple different means to make sure that we're understanding what's going on elementally with those dust particles. And then key types of where that dust was probably coming from was identified using some statistical tricks. And so let's take a look at what some key findings here. First of all, each of those particles at all those stations, we can see over here, It's a little bit small, but you have different colors for each of those sites. So we have the Sunny Bono, the Worcester, and all the different sites down there in different colors. And then over here, we're looking at something called an enrichment factor, which in essence is talking about how much more of this stuff is present in that dust than what you'd expect with, say, pure desert dust. So when every time that you see something that's right around 1, it's saying, this is about average for this particular area. You'd expect that much. When you have these box plots that are significantly above that, that's saying that we're seeing more than you'd expect based on other kinds of tracers in that dust. And this usually indicates some sort of antigenic or human influence on that dust, making it different than what we'd expect from kind of normal desert dust. And so you can see we've got a bunch of different elements. We don't need to go through each and every one, but we have different pieces, different kinds of tracers that differs from station to station. And this is the overall kind of average here. We also see patterns that happen over time. So we're seeing different types of sources of this dust that are occurring in different locations, different times of the year. And so using these enrichment factors, we can kind of pull out different fingerprints of what kinds of particles are landing in these collection bins. Because of course, these elements, we don't get a single grain of calcium that just floats around. These are grains of dust, which contains some ratio of all of those different kinds of elements, or many of those. And that means that we can kind of pull out a fingerprint of what kinds of elements are most typical of that particular kind of dust, and kind of attribute that to different locations or different kinds of activities. So that was the statistical trickery that I was telling you about before, where they tried to pull out what were the fingerprints, what were the likely suspects that produced this particular dust at the station at this time. Once those have been identified, you can go back and look at soil analyses across the area and pin those elements that were in different types of dust to where they probably came from. So for example, we have a particular category that Roya and Alex pulled out here that was rich in uranium and calcium. And you can go to soil surveys and see where were those elements most frequently located along the region. And this suggests where we see that this is related to Colorado River inflows. And so this one was assigned the category based on where we see those particular elements. This was probably Colorado alluvium. This is probably dust that was brought in from the Colorado River. It's probably not native to these areas originally. And so this was given that kind of tag of Colorado alluvium. Meanwhile, we can see other types of elements, other kinds of fingerprinted elements that are enriched that are local. And so these are where we see all the areas that are not maybe right along that Colorado River influx, where we have high levels of these particular elements, the aluminum, the iron, titanium. So this is where we can kind of fingerprint dust, where we have these tracers that are enriched as probably being in this category that they've ascribed as local alluvium. So in this manner, each of the different types of factors, each of the kind of key dust sources in all those collections over different months and different locations were then pinned down, and they pulled out 7 different categories and looked at those over time. So again, the 5 stations are over here. These plots, I'm not going to go through in too much detail. If you'd like to see the paper, they describe them in painfully excruciating detail, all the bits about why they chose this particular type for that particular pattern. But very simply, we see that the yellowish colors means there was not a whole lot of that particular bin in that location at that time. And the darker, as we get to darker and darker blue, it means that it was taking up a larger and larger fraction of dust in that area. Along the bottom, we have from left to right, we're going across the year from May until the following April. And then the stations over here from top to bottom are each of the different collection stations. And so we can see spatial and temporal patterns as far as where the dust was being collected and where that dust likely came from. One of the key takeaways that I'd like to just really suggest here, and what's of strong interest to me, is that not all the dusts are created equal. Not all these dusts are made up of the same thing. And elemental composition is only one possible way that we can dissect what's in these particular particles. So we get different patterns at different times of the year, areas where we don't have so much of the Colorado alluvium. There's a seasonal cycle, and times of year where we do have more of it. We also see differences from station to station, and that's true from each of the different factors that they identified. Colorado alluvium, local alluvium. There was also a source that was coming directly from the playa. You can see that it was, in most cases, constrained to be very, very close. This is the Sunny Bono site down in the east of the sea there. And it's also very, very close. Unfortunately, and this again is one of those areas that we're hoping to, for further work, kind of investigate more. I'd love to get more all the way around the sea. We don't have areas, we don't have sites set up where we have that kind of close proximity in all directions. But we do see a strong playa source from the elements that were ascribed to playa sources in Sunny Bono site. We also have some that's associated with sea spray from the sea itself. The sea itself is an emitter of particles. You get little bits of droplets, and those have their own chemical properties, their own little bits of ways that they can interact chemically, and then, of course, if they go into the human body with us, with people. And then finally, we also have some bins that were associated directly with human activity. So these are trace metals that we don't tend to find in desert dusts. So anthropogenic trace metals, kind of a weird one where we see some large spikes of copper, and these are associated with human activity, typically combustion, industrial activity, roads, all these kinds of things that humans do that kind of generate our own emissions. And then, but one more source, agricultural burning was another one that popped up as having a seasonal cycle with some spatial patterns and distributions. And so with all these factors, which of those, one question that was raised in this paper was, which of those do humans influence? It's always an interesting question about what kinds of activities that humans do can influence different emissions for the air that we breathe. And if we look at those sources, obviously the anthropogenic copper and trace metals, that's from stuff that we're burning. We're burning or we're doing industrial activity, that's straight from humans. The other ones, Colorado alluvium and agricultural burning, that's still related to human activities. That's agriculturally driven. Choices that we make on our farms or with our waste, those will influence how much of those dust particles reach us. Playa and sea spray, that's going to be related to water management indirectly, so we have some influence on what's going on with those particular particles. And so there's a big chunk of all those. If you sum all these together, there's a huge chunk of the total dust that actually is directly or indirectly related to human activity, which is one of the points of this paper. Altogether, you can identify different patterns in the dust composition over space and time. So each of the stations, you can look over time. This is a nice little set of figures they put together, looking at how much dust there was and what fraction of it was associated with each of those different bins. And then we can look at all the different sites together and see where we have more of an influence of different pieces. So in the Palm Desert, you can see a strong influence from the local alluvium, a little bit from the Colorado, more of the Colorado influence, say in the Worcester site, and then the Sunny Bonos, where we have a big influence from the playa at different parts of different times of the year. So interesting how each of these different factors comes together when we look at the spatial differences there. Now, one thing we know, of course, is that there's a big caveat here when we look at the Sunny Bono site, when you see that strong playa influence, is that as you've seen from multiple talks going on, is that source is expected to increase. And so that's going to be something that over time is not going to be constant. One paper that was that addressed this recently, last year, there was a paper including from Charlie Zender over at UC Irvine, where they actually looked at if you were to increase the emissivity of those playa edges, what kinds of, this was a preliminary study looking at what kinds of magnitudes of changes you would see in that local emissions. And they were looking at, in some areas and times, they were just looking at individual events, up to 10 times higher in some locations. So in terms of what that playa source is going to be, this is kind of we've talked about this already and we'll continue to do so, is that playa source is going to increase. And so we expect that piece of the dust puzzle to get bigger. So overall conclusions from this paper, we're looking at Alex and Roya's paper. They're looking at temporal and regional influences of different dust sources. They identified 7 different sources based on the fingerprints of the elements that were contained in those. And the sources altogether accounted for 55 to 8% of them could be influenced by human activity. So there's a big chunk of the dust in that area that is influenced by choices that we make as people in the area. And then those playa emissions have a temporal pattern. They're most intense in the spring and early summer. And those playa emissions, as we've seen before, again, are expected to increase over time. I'm going to divert any really tricky questions about this over to Dr. Roya Bahraini. She couldn't be here today, of course, but I know that she'd be thrilled to take any questions about this particular paper. And then to wrap up here, I'm just going to ask another question. When I came here last year, one of the big takeaways that I came away with was that there's been a ton of research of this nature on the Salton Sea, on playa, even on playa emissions. One of the key, I think, dearths of information that we have not yet explored, at least not nearly enough, is what are the influence, or what does this mean for people? It's the people that we're looking to help here, right? It's the people that are going to be breathing this dust. It's the people that are going to be driving, at least in my case and for my work, it's the primary motivation for what we're trying to improve when we're looking at dust control strategies. And so I'm really happy to introduce the Breathe Center over at UCR. It stands for Bridging Regional Ecology, Aerosolized Toxins, and Health Effects. This is an interdisciplinary team, many different types of backgrounds, epidemiology, microbiology, atmospheric scientists like myself. And the overall goal is looking at how these different kinds of constituents interact with humans in terms of health. What are the health outcomes that come from this? I know that we'll hear more about this topic in just a little bit. One of the things that has been done by the Breathe Center is to take those same kind of collection patterns and look at what's happening to mice. So we're actually looking at living tissues and seeing what kinds of responses are seen when different types of dust are exposed to animals in different types of chambers. And one of the outcomes of this that has been seen is that we do see some differences, some really interesting differences that I think underscores the notion that it's not just about the total mass. We have a lot of measurements over decades about what's the total mass of particulate matter in the area here and elsewhere. However, the total amount is not necessarily the defining factor if we see strong differences in where that dust came from. And so this was a look at what happens within these types of in types of tissues and immune responses when we expose Salton Sea dust to mice. What we see is a strong response in particular types of white blood cells, neutrophils, that we associate with other kinds of health conditions. What's interesting about this, to me, is that when we then expose other dust from other areas, such as from Palm Springs, so go further north, we do not see that response. This is the gray bars that we're looking at over here. And so this seems to be a response that's unique to dust that's coming from right off the Salton Sea. This is something that's different from just saying the total quantity of the dust. This is indicating that it may be the type of the dust that can be indicative of risks to human health. So I think this is very important. So what is it in the Salton Sea dust that's causing this response? This is the million-dollar question, and this is what we're still working on. This is ongoing work to identify what's going on within this dust, to identify what types of responses we can expect from this dust, and then to look at how, next step forward, how that's contributing to health outcomes within the Salton Sea area. So the Breathe Center recently secured a large NIH grant, a 5-year grant, putting together the center that's specifically focused on looking at the factors that are driving disparities in childhood asthma and other health conditions, and the Salton Sea dust component is a big part of that. And that's one of the pieces that I'll be working on. And furthermore, this is not simply just another paper machine that we're working on here. This was designed from the ground up as being collaborative with the local community. We have a community action board that's going to be going every step of the way and looking at how these outcomes can be communicated to people, how solutions can be devised along with community support to make sure this is a very hands-on, grassroots, locally connected effort. So I'm really excited that this just is starting this year. So this will be for the next 5 years. We'll be putting this together and bringing ideally more results each time that we have this particular summit. We're also looking at expanding more collection sites, more methods. Elemental composition, as I mentioned, is only one way that we can kind of look at what's in that dust. There's all kinds of compounds, organic compounds, different types of spores, fungal activity, chemistry that can be going on that wouldn't necessarily show up as ratios of iron or ratios of titanium. And so we're bringing on more measurements, more types of analysis over these next 4 or 5 years. I'm also excited, I can say that the Breathe Center director, who was instrumental in securing this grant, put this together, Dr. David Lowe is right over there. He assured me that he's thrilled to answer any questions about the center or about the grant that was put together. And so definitely track him down during one of the breaks if you have some more specific questions about that. My part is going to be looking at the transport and exposure of this dust. This is just a little teaser of some of the work that I'm doing. Once we know the differences about this dust, we can look at where it's going, and we can kind of attribute that, ideally, to maybe different kinds of health outcomes that we see in the area. And with that, we know that the sources in the Salton Sea region show differences in composition and in the health impacts. It's not just about the total mass, it's also about what it is and where it's going and where it came from. Ongoing work can help answer some of these key remaining questions, and to be fair, there's way more questions right now than answers. That's where we as researchers and members of the community, we have work to do. And then improving the health and reducing health disparities is going to require an all-hands-on-deck approach. So holistic, many different kinds of scientific disciplines, involvement with the community, and actively working with everybody to find some solutions to these issues. Thank you very much.
All right, our last talk in this session will be Shohreh Farzan, the public health impacts.
Hi everyone, thank you to the organizers for inviting me to speak. I'm excited to be here. I'm from USC, and I'm excited to talk to you about our children's iris study, which is A really collaborative study. We partnered with Comité Cívico del Valle in Raleigh, as well as University of Washington and Tracking California, which is part of CDPH. So you've heard a lot about the shrinking of the Salton Sea. So I'm not going to focus on this, but just tell you that we got into this work because we're really interested in the public health impacts of what this playa exposure may mean. So we know that there are a number of sources for windblown dust in this area, which may be due to not only the sea, but also desertification, changing climate. But we're really worried about the particulate matter that may result. So increases in PM, so PM10 from coarse dust, PM2.5, more fine dust that may result from vehicular emissions, as well as from some of these windblown dust sources. What we don't really know, but we suspect, is that the playa dust may carry a number of heavy metals, as well as pesticides, salts, all of these runoff materials from agriculture. But what we do know about PM is that it can penetrate deep into the lungs. So PM10 tends to affect the upper respiratory airways, and PM2.5 can transport deep into the lungs and cause some of these health effects. We know that there are a number of respiratory health effects. They can harm lung development, exacerbate asthma risk, affect brain health, both brain development as well as brain aging in older adults, and affect cardiovascular as well. So while we don't know exactly what may occur around the Salton Sea in terms of health effects, we can look to other examples, like the Aral Sea and Owens Lake, to get a sense of what we might be dealing with. So in these cases, Owens Lake here in California, the Aral Sea on the border of Uzbekistan and Kazakhstan, both of these saline lakes have receded. Owens Lake, after the water was taken for primarily for LA County, was one of the largest sources of PM10 in the U.S. until mitigation efforts were implemented. The Aral Sea is continuously emitting dust now, and some studies around this area have found that there are effects on children's kidney function as well as lung function. One of the issues around these two areas, though, is that we don't have data from before these drying events occurred, and so we really can't say how much of the health effects have really been attributable to the emissions from these areas. So what we were really concerned with was the community concerns around asthma prevalence. And so our community partners came to us and asked us to focus on respiratory health. And this is because the incidence of asthma in Imperial County is almost three times the U.S. rate among children. And it's actually quite a bit higher than the state averages overall. And so we're worried about air pollution from the shrinking of the sea, but also other sources of air pollution in the valley, as well as diesel pollution from truck traffic and train traffic and transport of goods through the area, as well as agricultural activities, including burning, pesticide applications, etc. So there are a number of environmental health concerns that we have to contend with in the Imperial Valley. And so I'm going to tell you a little bit about our study. And our study focuses primarily on windblown dust emissions from the receding shoreline and how this may affect public health in the Imperial Valley, particularly for children. So our study aims to establish a cohort of 500 children. These children are primarily enrolled from the northern end of the Imperial Valley to assess respiratory health. We're working with 5 elementary schools currently. You can see here on the map. In yellow, I'm missing a dot down here. Here we go. So we're working with these 5 schools, and we're actually going to the schools. We've been in the schools for, I guess, almost 3 years now. in a pilot phase, and in the last year, we really implemented this study. And so what we're doing now is we're going back twice a year in the fall and the spring, and we are administering a questionnaire to parents we send home about respiratory symptoms, and then we bring our mobile clinic and we collect data on height, weight, blood pressure, lung function, etc. And then we're pairing these data with an assessment of air pollutants in the area. And we'll talk about that in a second. The overall goal of this study is to use these data that we'll collect over the next several years to help establish community health education values. So as I mentioned, we partner with CCV, located in Bali, and we're utilizing the Community Air Monitoring Network, the IDA network, to assess particulate matter across Imperial Valley. And so you can see here, this is a map in blue. These are all of their monitors. They have 40 Dylos monitors that are particle counters, and so we can get a sense of both PM10 as well as PM2.5. And then we have, at each of our schools, there's also a monitor. Additionally, at each school, we've put up these crazy things that you see on the right. And so these are pumps that pull air through filters that are protected under these sort of hat-like devices. And so we can collect 2-week integrated samples of particulate matter, PM10 and PM2.5, to get a sense of what's actually in the dust, what's reaching the communities. As I mentioned, we're assessing lung health, and we do this primarily through a symptom survey that's administered twice a year, but also through spirometry. So we take spirometry measurements of our children. This measures lung size and function, and then we're implementing this measure of inflammation in the airways as well. So just to show you a few preliminary results, these are from last spring. We're currently in another data collection phase right now, so we're hoping that we would hit our 500 children, but in the spring, we were at 487 children enrolled. These are overwhelmingly Latino children. We have about half boys and girls. This is a pretty well-insured population. About 3/4 have public health insurance, and another, what's the same thing now? But about another 15 to 20% have private health insurance. And the good news is most people report that they are not smokers. And so the children aren't being exposed to smoke in their homes. And they also are fairly active kids. So these are 2nd through 4th graders in this time frame, and about 40% are playing sports at least twice a week. When we look at respiratory health outcomes from our survey, we see that the prevalence of asthma actually mirrors pretty closely what other studies have reported. The Boston study, as well as a few other estimates of asthma in Imperial Valley. So we see about 22% reporting doctor diagnosis of asthma. And we see fairly high percentages of children reporting lifetime wheezing, allergies, as well as some of these other symptoms that may be related to respiratory impairment, like dry cough or bronchiolic symptoms. This is when we split it out by asthmatics versus non-asthmatics. As you'd expect, asthmatics report higher incidence of some of these symptoms. However, we do see fairly high rates of wheezing, allergies, and then these other respiratory impairment symptoms, like dry cough or congestion in the night, that might indicate that there is some level of underdiagnosis of respiratory impairment among these kids. So the plan is to integrate all of these, this rich health data with all of our exposure data that we're collecting, not only the filter-based sampling, but also the air monitoring data from the IDA network. We're disseminating information. Whenever we get the chance, we try to send home infographics to parents and teachers and schools to try to let them know what we're doing, what we're finding. And all of this is to help us understand what's really going on in the community, what are the needs, and develop a community public health action plan. And hopefully this will support policy changes as well as health supportive changes in the schools and locally as well. So I'd just like to thank my collaborators as well as our funding from NIEHS. This is our mobile clinic, so if you see us around, please stop by and say hello and see what we're doing. And with that, I'll take questions.
Thank you so much. We'll open the session to questions now.
My question is regarding the epidemiology work. When you're looking at populations such as those in the Imperial Valley, wouldn't you want to compare against another farming community population that wouldn't be near the Salton Sea? My wife's family grew up in, say, southern Colorado or something like that, where it's hot and dusty as well, but it doesn't have that Salton Sea component to do. What is actually the problem or the issues with the community? Is it for Salton Sea versus a general desert type environment that many people would see?
Yeah, that's a great question. We may be a little bit limited in our exposure analysis. We tried to choose schools that we thought might be more impacted by actual playa dust versus agricultural sources. And so we have two schools sort of right up against the sea in Landon and Calicut, but then further away in Meadows, which is down near Imperial, which may be more impacted by agricultural sources. But you're right, it would be nice to have a comparison community, but we're a little bit limited in this area in terms of what we can do with gaining an exposure contrast, but that's a really great point.
Hello, as part of the air study, my name is Anna Vargas and I'm a community organizer in the Eastern Coachella Valley, and I also grew up in Garmo. And so growing up in an area, I can say that yes, I've been, it's a different environment, and I've spoken to many people. I myself suffer from an autoimmune, I suffer from lupus, and so I tend to be extra sensitive when it comes to, I can feel when, and I have the app from South Coast Air Quality Management District, which is great. And I noticed during the summertime, because I do organizing out in the community, that in the summertime about, I would say on average twice a week, the air quality index would go from moderate to over 100, which then would be basically the air quality is not healthy, especially for sensitive groups. And so that would sometimes even be over 200. And then just a few weeks ago, we had like this really bad dust storm where it literally went from 50 on the air quality index to 500 within like a span of an hour. And actually a storm came in that day. And so it just goes to show that we can't control the environment, and it's unpredictable at times. And I live currently in Indio, North Indio, which is on the north end of the expressway, and we have a lot of dust. So I guess part of my question would be that through this study, based on your findings, is there going to be like a public health awareness campaign to help individuals, one, to inform them, about what is it that contaminants, what they are, what is particular matter, other pollutants, and the risk associated with those pollutants, and also ways to mitigate and prevention, to reduce exposure, especially for sensitive groups of children, elderly, and individuals like myself. And so I was just wanted to give an overview, but yeah, speaking from my personal experience, living in an area where there's agriculture, the Salton Sea does, yes, it does have an impact on our health. So I'm very grateful that you're actually researching it because it's like a long time overdue to have a study of this type. So I appreciate that. Thank you.
Yeah, thank you. One of the goals of the study is to work with our community partners to develop a community health public action plan. And so that's going to be largely driven by what we see in our study, as well as what our community partners want to implement. One of the things that CCV has already implemented that is a great tool for public awareness is the flag program. So a number of the elementary schools, as well as middle and high schools in the area have a flag program. So they check the air quality and they actually raise a flag, green, yellow, orange, or red, depending on air quality. And parents that may not be so aware of some of these measurements ask about the flag, and so you can get a sense of how the air quality is. And the schools actually use this as a tool to keep kids inside or to be more sensitive to asthmatic children if the air quality is bad. And so, we're trying to develop other things like of that nature that we can implement.
Just tack on real quick. That question about what can be added to this communication is, I think, also central to the work that we're trying to do in the Coachella Valley. That AQI, the Air Quality Index, is based on PM 2.5, PM 10, which is just the total mass, but it doesn't communicate what that mass is about. And so, if there's something we can add on to that, some extra value, say AQI 100 may mean something different depending on which direction the moon's blowing. And so, if that's something that we can contribute, especially to at-risk populations or those who have other health risks, adding that extra bit of communication is definitely one of the outcomes that we're hoping to accomplish. So, yeah.
One question for whole panel, if I may. I'm sorry that Secretary Crawford already left. I wish if you can hear my question and your answer. It's a difficult question. It came to my attention recently that there is 120 pounds uranium at the southwest corner of Salton Sea from World War II. Did you find any radiation in those air particles, or you miss it to report it, or you didn't find it yet? And I hope Army will take care of that so before you really find those particles in air. Thank you.
I don't believe any Geiger counters were involved in the paper that I produced, but you did see U was up there. Uranium was one of the elements that was examined. From what I understand, there was no concentrations of uranium that was deemed to be itself a toxic risk, but it was a trace metal that showed up in some particles. Whether or not that was related to the event or to the source that you described, I'm not sure about that.
Given the location of the off-road vehicle recreation area to the west of the Salton Sea and the significant emissions from that site, plus the nature of the prevailing winds and concerns about saltation being an important process that exacerbates emissions from the playa itself, has any consideration been given to the possibility of closing that off-road vehicle area?
The Imperial County Air Pollution Control District has asked the Air Resources Board for assistance in determining the contribution of wind-blown dust from off-road vehicle areas, such as Ocotillo Wells. And we have offered them a proposal which basically would attempt to map out emissions from all of the areas upwind of communities in the valley, Imperial Valley, until we have a complete inventory of wind-blown dust. We can't tell you what the relative contribution is of the off-road vehicle areas. We do know that there are areas, for instance, the Utah Desert, which showed up in red in Brian's emission heat map, is an area that is not as disturbed by off-road vehicle travel as the regulated parks. However, the soil texture containing increased concentrations, percentages of sand provide a natural source, but we don't know also how that emissions from that compare to soils that are disturbed within the valley itself. So we're working with Imperial County APCD to find funding to do additional monitoring and analysis to try to answer that question.
Yeah, Amato Evan from the Scripps Institution of Oceanography. My question was actually really similar, and it was just that, like, how do we gauge success in mitigation and what we're doing if we don't really know how much dust is coming off the playa right now? We don't really have a baseline. And so, like, you showed the trend maps or like maps of the last few years. Okay, well, there doesn't seem to be an increasing trend in 10, but then if you look at wind maps, for the same time period, it does appear like there might be a decreasing trend in how windy it is. So it's certainly plausible that emission has actually been increasing, and that increase has been masked by a change in the meteorology. And similarly with like the heat maps that we were looking at, I mean, one could think that dust blown off the Anza Desert, right, is acting as a saltator on the playa, but that's not picked up by the pi swirl measurements, because that's only getting, right, you've got this little can over the desert, right? So you're not like throwing in Anza Desert dust into the pi swirl before you do your measurements. And then similarly too, if you look at the desert regions that you showed, particularly to the south, like your heat map was blowing up along the border, like along I-8. But like that's a really rocky area. I mean, when there's dust storms, there's not a lot of dust being emitted from that region. If that were the case, you know, Calexico, El Centro, like PM10 would be through the roof and way higher than Salton Sea. That doesn't appear to have happened. So I'm just curious, like, how do we create a baseline right now by which we can measure success in the future with regards to mitigation?
There actually has been quite a bit of work done to estimate how much dust is coming from the playa. Over the last 2 years, we've seen it increase by about 20%, but the numbers are still relatively low. If I go back to my slide set, I think it goes from 350 tons to 450 tons on an annual basis coming from the playa. There's been intensive monitoring to generate that number. More monitoring has been focused around the playa. We have looked elsewhere, you know, because we do understand that there are a lot of emissions coming from the neighboring sources, but the same amount of data collection and mapping being done on multiple millions of acres is very different than 20,000 acres. And I think that's part of what Earl and Imperial County is interested in is increasing the accuracy of that off-lake inventory to really understand what is coming from off-lake areas. And it's not the dust itself that's from the Anza Desert that is creating and making the Salton Sea more emissive. It's the sand, it's the abrasion agent. And that sand comes down in two ways. It comes down adjacent. There's several sand dunes that are actually cascading at some of them over 50 feet a year towards the playa and knocking on the door. They're coming. We've done several tours to bring awareness to that. If those come onto the playa, what would be relatively non-emissive surfaces become 5 to 8 times more emissive. So stopping that is definitely important. The other way it comes on is in flash floods. So when those floods come down, those alluvial washes and the dry washes and the alluvial fans, they bring sediment with them. Earl showed that, and that sediment is not winnow, has a lot of silt and other smaller PM10 size fraction in it that can contribute and ultimately gets reworked when it's on the playa and becomes even more of a problem from a wind standpoint. But I guess I would disagree. We do have a very good understanding of what is coming from the playa and where right now. And that is going to continue into the future in terms of helping provide guidance towards where projects should be on the playa.
Okay, in the interest of remaining on schedule, I think we have time for just one more question before the break.
Okay. So didn't the data from Earl Withycombe show at least 100 times as much emissions from the desert as from the playa? So that should be a focal point for epidemiologically
You mean
studies.
the paper by Charlie Zender?
I think both showed 100 times as much emission coming off the desert as opposed to the playa.
The Zender paper was only looking at local emissions, and so he found, with over time, 10 times more emissions from the receding shoreline.
Yeah,
He wasn't looking at outside sources though.
maybe Brian can speak to
Maybe,
that.
yeah, maybe that was.
Yeah.
Yeah, like I said, so we did look at the desert adjacent to Salton Sea. We estimate those at, I think we saw, 120 to 125 tons per day. That's very consistent with the previous emission inventories that have been done back in 2009 by Imperial County Pollution Control District. And I guess, again, we're looking at those areas from, like I said, from a couple different standpoints. One, it impacts our project physically, and the other one, it impacts it from a standpoint of not knowing when those plumes come off the desert and mix with anything potentially coming from the playa, it becomes very difficult to understand what is actually coming from the playa, and the visual tools are less useful. So that's why we've been focusing on that area. But yes, you're right; those are large numbers, but they're consistent with previous work that has been done by Imperial.
All right, I want to take this opportunity to thank the speakers for the session today on this
Okay, well,